So this is a brand new presentation because Matthias let me submit 3 different talks, and in the end he told me, yeah, but I would like a 4th one. And he was the one who kind of not designed the talk, but at least suggested me the exact topic he wanted. And Matthias told me he wanted to learn how developers can benefit from Groovy and how it's being used, when, in which situations, etc. So that's why I created this brand new presentation for JFocus. So you have exclusive content. And before going any further, if you're interested in Groovy, Grails, or the Groovy ecosystem, there's a Groovy is group here in Stockholm, so don't hesitate to join the group and learn more about the cool technologies that we have in our ecosystem. So I'm Guillaume Laforge, and I'm the project lead of Groovy. I've been working on Groovy for the past 10 years already, and I'm working for Pivotal. A couple of links if you want to follow me on Twitter and my blog and so on. And to tell you about Pivotal, that's the old Spring Source VMware stuff, plus a combination of some of the things like Cloud Foundry, like Greenplum for big data, all the stuff from the old Spring Source, all the Spring platform, all the cool stuff around RabbitMQ, Redis, and so on. So all those things are Pivotal. At least that's my definition of Pivotal, my company. So this talk is not so much about Groovy, an introduction to Groovy, what's the syntax, what are all the features that we have, etc. So I won't spend much time, actually no time at all, on explaining you all those details. But I'll really focus on the various use cases. So in less than 5 minutes, what Groovy is an open source project. It's an alternative language for the JVM, and actually a quite popular one. It's an object-oriented language, so all you know from Java, classes, interfaces, abstract classes, and so on, all those concepts are exactly the same in Groovy. There will be some additional things. For example, in the upcoming Groovy 2.3, we'll add traits, so it's something that's not in the Java object orientation, if you will. But if you know Java already, and I'm sure you all know about it, it's the same object orientation. Groovy is also a dynamic language because there's a runtime, so we don't directly invoke a method, but we go through a runtime and asking it to invoke that method for us. And it opens the door for various features that will be illustrated in some of the examples later on, like the Groovy builders and other features, like how to add properties to numbers dynamically and that kind of stuff. That's because it's a dynamic language. But it's also got a certain functional flavor thanks to the closures. Groovy's had closures for, since the beginning, basically. So we didn't have to wait for Java 8 to have our first-class functions, first-class citizen functions. We've had closures in Groovy. And around closures, there are tons of things like all the map reduce filter stuff that you can do with, if you've seen some JDK 8 talk about lambdas and streams, we've had that kind of APIs in the Groovy development kit for a long while. And we can do things like carrying closures and more functional aspects. So Groovy is already a kind of blended language in the sense that it's got several flavors. It's object-oriented, it's dynamic, but it's also functional. And although being a dynamic language, we also added static type checking and even static compilation. So when you want to have the same kind of feedback as Java-C, when you use the Groovy-C compiler, you can use static type checking to get compilation errors rather than runtime errors when you make typos in method names, in variable names, and so on. And for the hotspots in your application, you can also tweak and turn on the static compiler to statically compile certain parts of your application, certain parts of your Groovy code, so that it produces more or less the same bytecode as Java-C. So you can make Groovy as fast, as safe as Java as needed. It's up to you. But if you use static type checking or static compilation, you might lose certain dynamic aspects because, well, that's a trade-off. So you have to choose what you want to support and what features you want to use. And I said it was a pretty popular language. Just a few weeks ago, I computed some stats. Some download stats for Groovy, and for last year we got 3 million downloads, which is a pretty nice figure compared to last year where we had, the previous year where we had a bit more than 1.7 million downloads, so it's almost doubling in terms of download numbers. And it's used by a bunch of companies. Groovy is used by all of these guys in a way or another. So for example, when I put Google, it doesn't mean that Google has a project using Groovy per se, or say Gmail or whatever, no big projects like that using Groovy. But for example, the Android SDK is now using Gradle, the build tool based on Groovy, to build Android applications. Or even in the Android SDK, actually, there were some tools in the SDK which were already using Groovy. And other companies, like let's say Netflix, are actually users of the Grails web framework, which again is built using Groovy. So all these companies, in a way or another, are using Groovy. And it's just a list of a few that I found, and I used the most, let's say, the most famous ones. So we'll be speaking about big use cases. You know, the Groovy logo is a star with 5 branches. So I tried to group the big use cases in 5 different categories, one for each branch of the star. So we'll start with scripting. So all the, the stuff you could do on the command line in your shell and so on. Groovy is also adopted inside projects, inside companies through testing, because we've got some interesting testing frameworks. Groovy is also being integrated into existing Java or pure Java applications, not necessarily a full-blown application made in Groovy, but just embedding some Groovy to extend the application for configuration, for business rules, for extension points, plugins, and so on. And the last one, the fourth one, sorry, DSL, domain-specific languages. And actually, for those 5 big use cases, there's a bit of an overlap with DSLs, because users of Groovy, library authors, framework authors, etc., are often turning their libraries, their framework, their apps, etc., to leverage the domain-specific language capabilities of Groovy to make nicer APIs. So there's a bit of DSL in those 5 branches, but I'll focus a bit more on some concrete examples of Groovy DSL for some companies. And the last one is for those using Groovy for full-blown apps. And when I say full-blown apps, it's apps, for example, built with Grails, where you develop the whole application in Groovy. So it's not a mix of Java and Groovy, it's really in pure Groovy. Okay, so for each of those use cases, I'm trying to split that somehow in 3. First of all, what for? For what kind of tasks are we going to use Groovy here? Then who, which companies, which kind of projects can leverage Groovy for that particular use case? or pattern, and then how. I'll give you some clues or some examples of how it can be used. For example, how you can write a Spock test when we'll be speaking about testing, etc. So for each of those use cases, I'll try to outline what for, who, and how. So let's get started with case 1, scripting. So scripting, so Groovy is also a scripting language because you can write freestanding statements without having to create a class. So you don't have to say class foo, static void main, string args, and that kind of things. You can just write the body of your main method, basically. It's really just a script. And Groovy comes with some command line tools like the Groovy command, which executes or interprets, if you will, Groovy programs. Scripting will speak also about build automation with Gradle, and we'll also speak about DevOps. So I regroup everything under the scripting banner. So perhaps it's a bit of a stretch, but bear with me. So Groovy is also a scripting language. That's what I said. You can easily run Groovy scripts from the command line with the Groovy command. And what's nice as well, although it's a language living on the JVM, you don't have to create a full-blown project with an Ant, Maven, Gradle build or anything. If you need some third-party library in your script, you can use the @grab annotation, and we'll see some examples of that later on in a couple examples. You just define @grab on some import statement, and you can say, okay, I want to grab, I don't have an example in mind, let's say a commons logging or whatever library you want to use. So you can just share a script and share it with others. You don't have to zip it, you don't have to create batch files or startup scripts or anything. You just send the Groovy script and people can use it right away, and it will download the dependencies in the cache and that kind of stuff. And there are some useful APIs that we can reuse. For example, we have a class called the End Builder, which reuses existing Ant tasks. So, for example, if you Ant comes with tasks for, let's say, SSH. So if you want to log into a remote server, you can use the SSH Ant task very easily from a Groovy script. And also, there are some facilities to easily invoke some other command line tools. So let me show you, first of all, who's using that? Well, basically you or anybody. So I don't have a particular company to illustrate that. Or, for example, the download stats that I gave you earlier for Groovy, I did that with a Groovy script because I had access to the Apache logs for our server, which is hosting Groovy, and I computed the stats by grepping through the logs. So I'm not a bash guru, so I had to use Groovy for doing that stuff to compute my stats. Yeah, so I'm not a bash guru. And I'll illustrate also with another example, which is currently where the Groovy documentation is hosted on Confluence, and we are migrating to ASCII Doctor. So ASCII Doctor, who knows ASCII Doctor, by the way? It's a bit like Markdown, but on steroids. So it's Markdown, but done better, more extensible, and more open. And there are projects like the Spring Framework and other projects who are migrating to ASCII Doctor in terms of documentation. So we wanted to reuse some of the content we had in Confluence. So we exported the content from Confluence, or perhaps I'll just show you this script. So we exported so it's very small, but I'm going to zoom in, don't worry. So we exported the content from Confluence into HTML pages. Then we used the HTML cleaner library, and I'm going to show you how you can grab that dependency. And then we clean the HTML, and then invoke a command line tool, which is PanDoc, which is a nice text format conversion tool that you can use on the command line. I think it's built in Haskell, if I'm correct. Then with that tool, we are transforming that into ASCII doctor. So it's just a Groovy script. So let's have a closer look to that example. So here at the top, you see @grab HTML cleaner, the group ID, the artifact ID, and the version. And I put the @grab annotation on the import statement. And this is how you can grab a dependency. So your script can leverage that dependency right away. Next, so I'm going to use the HTML cleaner class for cleaning the HTML that Confluence created. Then I'm iterating over all the files, all the HTML files and the directories. And then right at the bottom, you're going to see, so if you see, yeah, you see my little pointer. Here you've got a string, a bit of a long string actually, and you've got string.execute. Execute is a method that Groovy adds to strings, because Groovy, being a dynamic language, it can add methods to anything, and you can add your own method even to, classes which are final, like Java IO file or Java long string. So you can decorate classes with your own extensions. And I'm going to call execute to execute that command line, and then wait for the end of the process to wait for the execution of the transformation of HTML into ASCII doc format. So this is one example of a command line script that I'm using for a mundane scripting task. I mentioned that Groovy adds methods to existing types, to the JDK, etc. And we also have different APIs that you can use for your scripting needs. So I mentioned the end task that you can reuse. We also have a template engine, so when you want to generate some content, some code, etc., you can use the built-in template engine. We also have facilities for creating and parsing XML or JSON payloads. So if you want to interact with, and I think I have an example of that later on, where I show how it's easy to do an HTTP GET request, for example. I think I have that later on. I'll show you how easy it is. We have some simpler usage of JDBC with our SQL class, and we can also interact with the JMX pretty easily. So if you want to do some reporting of some components which are exposed through JMX, you can do that. So it's some of the APIs that the Groovy development kit provides that you can reuse in your scripting needs. So here's another example of how you can use the end builder, for example, with the mail end task. So, well, you define the host, from, to, address, and here you see I'm also using the marker builder, which is a class for generating HTML or XML payloads. So you see a bit of the structure of the HTML. HTML head, title, you see that those elements are nested if you follow or if you count the curly braces, basically. And then I can say message writer. This is the writer that I passed to the marker builder, and it's going to send an HTML email. Yeah, I'm zooming right. So this is the Groovy marker builder being used to generate the HTML, and here how I'm using the mail end task for sending an email and even adding attachments. Yep. And next scripting example is for build automation. Gradle is, well, quite successful. It's used in It's used more and more by various projects and companies. So it's a powerful build automation solution, and whose language of choice for defining your build, defining your tasks, etc. is Groovy. So you can build, package, deploy, etc. Java, Groovy, Scala, C, C++ projects. It takes care pretty nicely and with a fine-grained fashion of dependency management. It's more advanced in terms of dependency management than what you can do with Maven directly. And you can also define and enforce your own enterprise build configurations, conventions, so you don't have to follow strictly Maven rules. So you can define rules which may be different in your company. And you can easily extend Gradle both declaratively and programmatically because it's Groovy, so you can script your build if you need to, but you don't necessarily have to. And who's using Gradle? So I mentioned that the Android SDK is now suggesting and migrating progressively onto Gradle for building Android applications. Lots of the Spring family projects have migrated to Gradle, and Hibernate also is another example of a project, famous project, which has migrated to Gradle. So whenever you've got I would say, so Gradle is great even for pretty standard projects. No worries about that, but at least that's my take on that. I think that Gradle is even better for folks who have very complex needs. For example, for the Groovy build itself, because we do use Gradle ourselves, we had certain constraints for the kind of distributions, the deliverables that we wanted to produce. We couldn't have done it with Maven for various reasons. And only Gradle allowed us to extend and tweak the build to support what we really needed. But for a simple project, like a plain Java project, you just need to put something like that in build.gradle. You apply the Java plugin, you define where you want to, from where you want to retrieve your dependencies, repositories, Maven Central, and then you can define your dependencies. For example, I'm going to use commons collections and JUnit for my tests. So this is all you need for a standard Java project, right? So it's not very complicated. But if I showed you the Groovy build, it's quite a beast compared to that. Excuse me. So this is how you can declare a dependency. And I'm going to show you some extracts of the Gradle build for Android applications. So the Google guys from the Android team created some special Android plugin. So you can see here that we apply the plugin, and the plugin is defined and declared in the dependencies above here as part of the build script configuration. And then what the plugin did actually is really to write some kind of DSL, some declarative way of defining certain aspects which are important for the build of an Android application. So things like configuration, like the version of the SDK, etc. But for example, how it managed to create a notion of flavor, because when you build, so it's not just classifiers like in Maven, but it's something much more complicated or more advanced than mere classifiers. But you can create an Android application, the same Android applications, but in different flavors, a free app versus paid apps for a different platform, for a different a debug version or non-debug version, etc. So you can define that with that kind of DSL with the curly braces and so on. So this is not a real build, but I extracted some examples from the Android documentation for that. So you can really create your own mini declarative mini language for your build if you have particular conventions that you need to follow in your company. I'll spend a bit of time also on DevOps from a scripting point of view. There are some interesting projects going on in the Groovy ecosystem around DevOps. There's been a nice presentation from a company called iStats IT, not sure how to pronounce it, which created different useful projects for interacting with remote servers through SSH or work with Amazon EC2 instances. And also another plugin by a guy who works for Netflix now for doing provisioning. So I'm going to show you some example of that. So who is using that? Anyone, for example, who needs to deploy stuff on remote servers, or folks who are deploying stuff in the cloud. And I'm going to show those tools there. So another example of I'm going to grab that dependency on the sugar. Not sure if you should pronounce it like, sugar or... for example, there's a remote session method that you can call, where you define the machine you want to connect to. You can execute remote commands. You can change the content of a text of a configuration file, or you can do some SCP between your local machine and that remote machine. Remote execution. If you use the Gramazon tool, it's actually a Gradle plugin that you put in your Gradle build file, and you can, for example, start an EC2 instance with the various attributes. I'm not very familiar with Amazon EC2, but you can define like your image, your AMI, the kind of instance that you want to on micro and so on. So if you want to do the provisioning during your build to test something live in the cloud, you can do something like that. And they also have some other projects like PUnit, which is a Puppet unit testing library, and Imager, IMGR, Imager, which is a bit like the stuff like Docker, Vagrant, and all those kind of tools. So you can have a look at those projects here. I invite you to have a look at the projects from that company. And I wanted to mention also this provisioning Gradle plugin from the guy from Netflix. So you apply that plugin, and then you can do things like that. So you can install some images like a CentOS image on VirtualBox. You can define your network configuration. You can define the partitioning, the various parts, the mount points, and the different packages you want to install. And what else? Yeah, groups and packages and such. So it's very declarative, a nice declarative syntax, I think. And some post-install steps that you want, some commands that you want to execute. Okay, and here's the URL for that plugin. So that was for the scripting aspects, DevOps, build automation, and command line kind of scripting. Second use case, we've seen Groovy being adopted by companies often through testing, because Groovy allows you to create some nice testing libraries like the Spock framework, the Jeb framework, or EasyB. It's not really maintained, that one, but Spock is the most famous one these days. And Groovy has a pretty readable and expressive API to let you write tests which are expressive. So who's using things like Spock and so on? Well, many companies integrated and started using Groovy through testing. And let me show you some example with the Spock testing framework. So Spock, like Spock, the Spock testing framework, that's for enterprise testing, right? So let me show you an example of a Spock specification. So first of all, I use a grab statement to fetch the dependency. Then I extend the Spock length specification class. And then notice how the labels are reused. Notice how we can define method names which are actually strings. Groovy allows you to do that. And then all the stuff in the expect blocks are like assert statements. And here what I particularly like is the weak-like notation for defining data-driven tests. If you want to do data-driven test with, let's say, JUnit, it's a pain in the... and with Spock, it's much nicer because it's just like if you were defining a data table in a wiki format, basically. And perhaps I can show you one other little trick. It's readable. So here I make a mistake on purpose. I'm testing max. So the max of 7 and 4 is 7. So here there's obviously a problem. And if I run that, something that I really like about Spock is that it's going to show me what we call power asserts. Power asserts, so the assert statement here failed because there's a problem because, okay, A is 7, B is 4, the max is 7, but the expected value that I gave in my table was 4, although the maximum is obviously 7. And what's nice with power asserts is that you see the various values of all the sub-expressions of that assert statement, which is nice. You don't have to create tons of asserts for all the sub-expressions. You just create one big assert expression, and you can quickly spot where the mistake was, where things were not, or didn't have the value you expected. So it's one of the little things that I like about Spock. But Spock, let me come back to the slide, has more stuff under the hood. For example, you can do things like, do I have a queue here? Look at the way you can define stubbing or mocking or defining expectations in terms of the interactions you have with the mocks or with the classes that you have here. So, for example, when publisher send hello, you should expect one call of subscriber receive with hello as parameter and one call to subscriber to receive hello. Okay, and it's quite powerful because you can go much beyond that in terms of interactions and explain things like, okay, I expect 1, 2, 3 calls to the receive method, or any number of calls, or any one call with any argument, one call with one parameter, which is a string, etc. It's a very rich API for defining your interactions. Another example is JEB for web integration testing. Well, this one is also pretty explicit. So you can use HTML unit, Chrome, and Firefox drivers. And it's pretty readable. Okay, browse the drive. You go to some URL. You're checking that the content of the H1 title contains please login. You can easily fill the form and submit by clicking on the login button and do some further asserts. And then you can mix the two, JEB and Spock, to do things like that. Given you're at the Google homepage, etc., or when you put Wikipedia in the search field, you wait for to be redirected to the Google results page, and you want to find the first result link, which contains Wikipedia, etc. So you can make pretty readable web integration tests with that. and you've got some handy methods like wait for and so on to wait for slow loading pages. Customizing Groovy as a way to extend your applications, configure, create plugins, and so on. So some examples of guys who are using Groovy for extensions: Jenkins, Smart Things for the Internet of Things trend, or XWiki, second generation wiki. Let me show you that. With Jenkins, there are a couple of plugins which leverage Groovy. There's the Groovy plugin and the Groovy post-build plugin, which allows you to execute stuff for once the build succeeded. So this one is the post-build one. Once the build has executed, you can say, okay, if in the logs you notice that there are some messages saying, okay, this API is deprecated, you can add badges and labels, etc. And for example, here I add this little badge. That's from the Jenkins documentation, and so you can define some further feedback, or even you can fail the build if you want. So by saying build unstable, it became yellow even if the build succeeded, but you used a deprecated API, so it made the build unstable. The other example I wanted to mention is Smart Things, which is quite popular Internet of Things home automation solution. So it's using Groovy for extending, configuring all your devices in your home. And there's even a kind of built-in IDE to define the preferences, to define the tasks to trigger when someone comes back home, or when someone lights up some device. And the other example I wanted to mention is XWiki. So it's what I call second generation wiki, because it's not just about content, but it's also about being able to build apps on the wiki, which are usually apps which are more, let's say, content driven, with history, with annotations, etc. And you can, if you've got the programming rights in XWiki, you can extend, or you can, let's say, script your pages. For example, this little example, which is going to use the GitHub REST API. Here I'm using the JSON Slurper class, which parses. And the fun thing also is this line. You've got a .text property on toURL, and it's doing a HTTP GET and retrieving the content. So in just one line of code, you can do an HTTP GET request very easily with Groovy. You pass that to the JSON builder, and then you can produce some wiki markup to show in a wiki page, like the list of GitHub projects. So you can have in your wiki some dynamic content in your pages. So that's quite neat. So how you can do that? Groovy provides a rich API for embedding Groovy with the Groovy shell, with the binding class to pass variables in and out, with customizers to customize the compilation of Groovy. And we've got some other APIs which can be useful, like a special configuration API for defining configuration information. Now, case 4, what time? Yeah, I should hurry up a little bit. Domain-specific languages. So Groovy is really a great fit for domain-specific languages because of the malleable syntax, because of its dynamic flavor or dynamic runtime, to be able to do things like adding properties to numbers and that kind of things. And there are lots of users of Groovy who are actually using Groovy to create kind of mini languages which are tailored for their business context. For example, Mutual of Omaha, big insurance in the US, uses Groovy for defining risk calculation rules. So the actuaries write themselves, although they are not developers, but still they have a math background, but they are able to write Groovy rules themselves. The European Patent Office, who was one of my customers, they built a data flow language on top of Groovy to be able to fetch all the patent information from all the worldwide patent offices, turn that into a common pivot format, and then be able to reroute that or do some logic on those patents. Another of my customers, a German company who's got a platform for loan granting platform used by a lot of European banks. Every month they are actually using Groovy to treat 1 billion euros worth of loans, and is going through some Groovy business rules. So it's the kind of stuff which is pleasing when you lead a project like Groovy. Or Amadeus, the travel infrastructure company, which is using Groovy for customizing the screens, the logic of how you can pick up a flight depending on conditions, etc. They can extend the platform with Groovy scripts, and travel agents can send Groovy scripts to be run on the Amadeus platform to do that kind of customization. There's one case study here for the European Patent Office. So one example with Mutual of Omaha. One of the reasons why they chose Groovy was because when you do financial stuff, you want to have exact arithmetic, so you don't want to have rounding errors. And by default, Groovy uses big decimal. And that's why sometimes people think that Groovy is slow when doing arithmetics, but it's because they don't know that we used big decimal instead of floats and doubles. But you can also use floats and doubles, of course, in Groovy. So if you look at that math formula in Groovy, it's not very obvious in Java. Sorry, it's not very obvious what this formula is doing. If you have an error in your formula, it's not so easy to find out. Whereas, because we're using big decimal by default, and also because we have operator overloading, the formula looks and reads like that, and it's much easier to spot mistakes. So when you do financial calculations, it's nice to have both operator overloading and big decimal by default. The example with Hypoport, the German company, they wanted to define rules for when to grant or not a loan according to certain criteria. So they created a kind of BDD-like behavior-driven development syntax, given, when, then, and they used Groovy closures for doing that. So you can create your own control structure, given, when, then. And I've got so here I'm using a person immutable class in Groovy. And this is how we can do that. For example, if you have a method taking a closure, given closure, you can use that syntax in Groovy. Okay, so if you want to define several levels of curly braces, etc., you just have to have a method which takes a closure as last argument. And here I'm using some other tricks like maps of closures, etc., to have the chaining given, when, then. So it's just a very simple example of how you can achieve that. Another example I didn't mention, there's actually a paper about that. The University of Liverpool developed DSL for studying antimalarial drug resistance. And they did that in Groovy. And the funny thing is that it's in Groovy, but it's actually generating Fortran code for their simulator, their medicine or medical or biomedical, whatever it is, simulator. It's a Fortran simulator. So they use Groovy as a thin DSL layer, but generate Fortran code. And just to show you a friendly way of doing, take 3 pills of chloroquine after 6 hours with water. That's a pretty, English-like sentence. This is how you can do it. You can add properties to numbers with metaprogramming. You can do it also in a static fashion. And you can, and the fun thing also is that what we call command chains is in Groovy is when you have chained method calls, you can drop dots and parents. And this here, this sentence here is really the equivalent of the call in gray below. So it's perhaps not very readable in comments, but that's the kind of code that you need to be able to write almost plain English or Swedish or French sentences in Groovy. And last, I'll be very quick on that one, full-blown apps. So in the Groovy ecosystem, you have projects like the Grails web framework. You have Ratpack, which is I think I have a slide where I list them. You have Ratpack, a lightweight toolkit on top of Netty for defining web applications, microservices, etc. There's Gaelic, a toolkit for Google App Engine for deploying Groovy applications on App Engine. There's Spring Boot as well, which is an opinionated take on Spring by Spring, which provides a friendly Groovy DSL. We also have a framework called Griffin for creating desktop applications, and you have different view toolkits that you can use: Groovy FX, Swing, and others. So, as part of the ecosystem, you also have other projects that you can use to build full-blown apps written in full Groovy. But you can also mix and match. You could always have some Java classes if needed. So Grails is a full web stack. I'll just mention Grails here, based on Groovy and Spring. It's called everything for accessing relational data stores and NoSQL data stores with GORM. It follows the principle of convention over configuration to simplify how you configure things, following conventions rather than having to explicitly configure everything. You have hot reloading, you have advanced REST async support, etc. And there are well-known companies using Grails. For example, Netflix with its Asgard platform, which is a solution for deploying and managing the deployment of the Netflix infrastructure on the Amazon Web Services platform. LinkedIn is using Grails for the applications for recruiters, companies and so on, searching for profiles. Sky in the UK, who have all their portals written with Grails, and they are serving 100 million. Last I heard was 200 or 300 million page views a month. Or Wired, where if you go to the Wired website, the section on product reviews actually built with Grails. But as my friend Graham Rocher could say, it's too hard to... so I put those words in his mouth, he didn't say that himself. But I don't have that much time to cover everything, and I can't dive deeper in Grails itself. So just go download it and have fun. So in summary, Groovy is cool, of course. It's really Java's best friend in the sense that it's very easy to learn because of its familiarity and its common roots with Java. It goes beyond Java because we have a more relaxed syntax, although most of Java is also valid Groovy syntax. But it's also a great fit for domain-specific languages, for business rules which are really tailored for a certain business domain. And I didn't really mention that, but it provides a totally seamless and transparent Java integration, so you can really mix and match Groovy and Java together. There's really no language barrier to cross between the two languages. It's a multi-flavored nature because it's object-oriented, it's type-safe, it's fast, it's functional, as needed. Just pick what you really need. And there are various use cases, the 5 big use cases for scripting, build automation, DevOps. It's easy to embed and integrate in your applications for extending, for creating plugins, for configuration. They are nice. Frameworks for testing, great for DSLs and for full-blown apps. So thank you for your attention. And I'll put the slides on speakerdeck.com/Laforge. And I don't think I have time for a question, I guess. No? Okay. So please come to me if you have some questions to ask. Thank you.